We're on page 245. We're going to wrap up these practice problems. So for number 25, find the specified roots for each number. For number 25, the real fourth roots of 81. So keep in mind, there might be more than one. So watch the wording there, like it specifies plural roots. So let's take a look at what they're saying. So 25, x equals the real fourth roots of 81. So 4 root 81. Now remember, I can rewrite this if you'd like to as 81. The exponent of 81 is a 1, right? It's just not written there, but it's actually to the first power over my index of 4. So just keep that in mind. I don't want people forgetting if they are given a problem like this. Don't forget you can go backwards and write it as the fourth root of 81 as well. We can type this into our calculator. And that's going to look like this. 81. If you want to do anything above the cube root, like the fourth root, you'll hit y root x and then type in 4 for the fourth root, and it gives us 3. Keep in mind, though, this is an even degree root, right? This is the fourth root. That's an even number. Anytime you have an even degree, you're going to have to take the positive and negative version of that number. So I know for this problem, it's going to have to be positive and negative 3. Don't forget, there's a way you can algebraically do this if you don't have a calculator or you just don't want to use the calculator. I can start off with my original problem, x equals the fourth root of 81. Remember, what I can do is I can raise both sides of this to the fourth power. X to the fourth is just x to the fourth. The fourth root and 4, those just kind of undo each other. And that gives me 81. And then at this point, I can set this equal to 0. So subtract 81 from both sides. And then I can factor this. The problem with factoring this, the reason why I'm not going this route is because, this is just not the depth I want to go into with factoring. If this was a quadratic, I'd be happy to factor it and move forward. But once you get above a quadratic, like a cubic or a quartic is what they call this, you have to do other things. There's formulas you can use. You can do guess and check. It's just requiring a little bit more of an in-depth idea of factoring. Of course, you could do synthetic division or long division back when we did that, but I wouldn't go this route. I would just kind of keep it simple, use a calculator. You can use these on the tests, use your phone calculator, use a calculator just on your Chromebook or on your computer. Just Google, the fourth root of 81 or 81 to the 1/4 power. Just make sure if you're Googling this, you type it in like this, 81. And then the next thing is going to be a set of parentheses. Then you'll do 1 divided by 4, close out your parentheses. You need that exponent inside parentheses. Otherwise, what it's going to do is 81 to the first power divided by 4 if you don't use parentheses. So use parentheses. So for 25, x equals positive and negative 3. You might be thinking, just to touch on this again real quick, if this is only leading me to positive 3 and negative 3, we're going to have some sort of quadratic here. I think in this case, it's going to be positive 9. Remember, this extra quadratic, whatever you have left over, is going to give you imaginary roots. And again, we're not prepared to tackle that this year. This is more of a pre-calc thing. We're not going to do imaginary roots. So you can't take x squared plus 9 and factor it. There are no real numbers that multiply to 9 and add to 0. So that's why we're not worried about the extra part, the part that's imaginary. Just kind of ignore that for now, for these purposes. 26, the third root of 343. Okay. So what I'm going to go ahead and do is just type that in my calculator, the third root of 343. So 343, the cubed root is right there. So it gives me 7. This, and let me emphasize this as well, because number 25 had an even degree. So I had to take the positive and negative version. This is the cubed root. So this is an odd degree. So I'm not worried about, it's not x equals positive and negative 7. It's just x equals 7. It's not like I can get negative 7 times negative 7 times negative 7 to equal positive 343. It doesn't work that way. So just keep that in mind. If you have an even degree root, you're going to have the positive and negative versions of the number. If you have an odd degree root, it's just going to be the positive versions. 27, the real fifth roots of 1024. So the fifth root of 1024. 1024, the fifth root is 4. Now this is a fifth root. It's an odd number, the fifth root, so it's just positive 4. So x equals positive 4. And again, the reason why it's just positive 4 is because I can't do negative 4 times negative 4 times negative 4 times negative 4 times. So I can't multiply that by negative 4 5 times to give me positive 1024, right? 4 times 4 times 4 times 4 times 4 is 1024. But once I add in negatives, that would give me a negative 1024, which is not what we're looking for. So that's why the negative version isn't included when you have odd degree roots. The real square root of 25. So this should be pretty easy. So the square root of 25. Keep in mind when there's no index written here, it's just the square root. So the square root of 25 is positive and negative 5. Why? Because the square root is an even value. So even values, you have to include positive and negative, because positive 5 times positive 5 is 25. That's our radicand. And negative 5 times negative 5 is 25. So that's why you have to use both the positive and the negative. Rewrite each expression using a fractional exponent. So for 29, I'm going to go ahead and write this out. The fourth root of 16 squared. Keep in mind when I write this out, it's going to be exponent over index. So the exponent of it divided by the index. So 16 to the 2/4, and go ahead and always simplify 16 to the 1/2. 29, 30. The sixth root of 729, so that would be 729 to the 1/6 power. 31. The seventh root of x squared, so that would be x to the 2/7 power. 32. The fourth root of ab, so that would be ab to the 1/4 power. Remember properties of exponents, I could split that up and do a to the 1/4, b to the 1/4. Both of those are getting raised to the 1/4 power, but since that's all they're looking for, you can leave it just like that. What is the value of each expression round to the nearest hundredth if necessary? So 33. The fourth root of 25 squared. So let's kind of get a little fancy with this, right? We'll start off with the fourth root of 25 squared. I can rewrite that as 25 to the 2/4 power, right? Exponent over index, exponent over index. I can simplify that fraction to the 1/2 power. I can write this back into a radical as exponent over index. So 25, so the square root of 25, my exponent is 1, my index is 2. Technically, I don't need that there, but just to emphasize what's happening. And then the square root of 25 is positive and negative 5. So that's just a way, instead of just typing that into the calculator, this is a way you can walk yourself through it mentally and using algebra to get down to the problem without even using a calculator. So 34 negative cubed root of 125 to the 5th. Again, I can rewrite this, but it's not going to help me. I can rewrite this as negative 125 to the 5/3 power. But you can see that I can't simplify a 5/3 down. That's not helping me do anything. So one option is you can take this and you could just type that into a calculator. I'm going to show you the algebraic way, kind of like they did, I don't know, with example 2, maybe 3 or something like that. Does it say it? Example 3. Kind of like how they were talking about using the power to a power rule to rewrite this. Remember, I can split this up in 2 different directions, and let's look at both directions. Negative 125 to the 1/3 power, and then that would be to the, actually, I think I want my parentheses there, so ignore that outside one, to the 5th, or I can write that as negative 125 to the 5th power to the 1/3, right? It just depends on which problem you're looking at, or which one would benefit you more. I think taking 125 to the 5th power is going to give me a really big number, and then I'll take the cubed root of it, and then I'll end up with a number. Or this is more of a direction I like right here, because the cubed root of 125 is just 5. Right? 5 times 5 is 25. 25 times 5 is 125. So the cubed root of 125 is 5. 5 to the 5th power, I'm not sure what that is. Let me look. So I'm going to go ahead and show you this. I just did it on my calculator, but this is kind of similar to any degree radical. You can do the same thing with any degree exponent. So I want to do 5 to the 5th. So I'll type in 5, and then this button right here, x to the y power, that would let me plug in any exponent I want. So 5. So that gives me 3,125. So 5 to the 5th is 3,125. So my final answer would be negative 3,125. Keep in mind, watch your negatives here. This was an interesting problem. And I kind of got tripped up right here when I started writing too fast. I'm taking a negative of this. So when I cube root 125, I'm not cube rooting negative 125. I'm cube rooting 125, and that negative is just along for the ride to the very end. So keep that negative where it belongs on the outside of everything as you're working, and then you end up with negative 3125. Simplify each expression. 35, the cubed root of 8y to the 9th. The cubed root of 8y to the 9th. I like to do this kind of like I talked about in my instructional video. I like to think about this as the cubed root of 8 and then the cube root of y to the 9th. I just think about it in 2 steps. So the cubed root of 8, again, that's 8 to the 1/3. You can type that in your calculator. That's just 2, because 2 times 2 times 2 is 8. So that's going to be 2. I don't know why I wrote equals. Sorry. I'm taking the cube root, so it's not going to be positive and negative 2. It's an odd root, so it's just positive 2. And then y to the 9th. Remember, the way you can rewrite this, the cube root of y to the 9th is y to the 9 divided by 3, exponent over index, which is just y to the 3rd. So 2y cubed. Uh, 36, the 4th root, q to the 12th, z to the 4th. So for 36, again, think about it in 2 steps. I'm not going to write it out, but that's what I do. So this is going to be q to the exponent over index, and then I'll have z to the exponent over index. 12/4, that simplifies down to 3. 4/4 is just 1. So q cubed z is that simplified version. 37, wow. This is the 6th root, 729, a to the 24th, b to the 18th. So the 6th root of 729, no clue. $729. I'm guessing, let's say 3, but I could be totally off. The 6th root. 3. So that's going to be 3. But remember, this is the 6th root, so that's an even number. So I need to include the positive and the negative version of that number. A to the 24th, remember that's just 24 divided by 6, which is 4. So that's a to the 4th. B to the 18th, the 6th root of b to the 18th, that's 18 divided by 6, which is 3. So positive and negative, 3a to the 4th, b cubed. $38, 8, v to the 8th, g to the 40th. The 8th root of v to the 8th, g to the 40th. Kind of the same thing we did up there. Remember, v to the 8th, the 8th root of v to the 8th, this is all that's happening. You're taking v, its exponent over index, 8 divided by 8. You're taking g, exponent over index, 40 divided by 8. And then simplify, 8 divided by 8 is 1, 40 divided by 8 is 5. So vg to the 5th is my final answer. $39. Solve this equation. 1125 equals 9x cubed. All right. Again, when you're solving equations, you've got a variable, which is x, and you're trying to get it by itself. The first thing I want to do here is divide both sides by 9, because that gets me closer to just getting x by itself. So I have no clue. 1125 divided by 9 is 125. And then there's a couple different ways to think about this. I think the book was saying, I'm just going to take the reciprocal of 3, right? The reciprocal of 3, you're just flipping it. 3 over 1, the reciprocal is 1/3. So what I can do is I can raise both sides to the 1/3 power. X cubed to the 1/3. When I multiply those power to a power, 3 times 1/3 is 3/3, which is just 1. That's why they eliminate each other, and I'm left with just x. 125 to the 1/3. That's the same thing as the cubed root of 125, which is also just 5. $40. 6480, 5W4, 6480. So pretty much the same as number 39. I want to get W by itself, so I'm going to divide both sides by 5. So I get W to the 4th equals 1296. Again, kind of like we talked about up here, you can raise both sides of that equation to the reciprocal of that exponent. So I would raise both sides to the 1/4. But in this case, I'm just going to go about it a little bit differently. I'm just going to take the 4th root of each side. Remember, raising both sides to the 1/4 and taking the 4th root of both sides is the exact same thing. The 4th root and the 4 undo each other. I'm left with just W. And then the 4th root of 1296 is 6. Remember, this is the 4th root, so that's an even power, so I want both the positive and negative versions of that. 41, 270, 10q cubed. 270. So just like the other ones, divide both sides by 10. Get 27 equals cubed cubed. I'm going to take the cubed root of both sides, and then I get 3 equals q. An odd degree x or an odd degree root produces just a positive number. So it's just positive 3. 42, 256 equals 4h cubed to the 6th. Sorry. Same thing. Divide both sides by 4. I get 50, 512? No. Yeah, 512. No. 64. Man, what was I thinking? 64 equals h to the 6th. And just like I did before, I would take the 6th root of both sides. You could also raise both sides to the 1/6 power. Doesn't matter. It's the exact same thing. The 6th and the 1/6 just undo each other when you multiply them. 6 times 1/6 is 6/6. 6/6 is 1, so I'm left with just h. And then 64 to the 1/6, that's the same thing as the 6th root of 64. So that's what I'll do, which is 2. Because this is the 6th root, that's an even number, I've got to include the positive and the negative versions of that number. I have no clue why I wrote plus or minus 6. I just got 2. So let's try that again. Plus or minus 2 equals h. 43. Oh, last one. A small cube has, so this is the same thing as the water cube thing that was in the example 5 or 6. A small cube has the volume shown. So it looks like the small cube is the dark chocolate. If you remember the water cubes, that they gave us the large one. Now they're giving us the volume for the smaller one. So just keep that in mind. It's not going to be exactly the same, but pretty close. Its side length is 1.5 inches less than the second larger cube. So if this is 1.5 inches less than the second cube, this is going to be x minus 1.5, right? X minus 1.5. So for this problem, it would be x minus 1.5 cubed, because it's talking about volume. So volumes are always cubed, areas are squared. And then the volume is 85. So because this container, again, in the picture, I think I was totally off the screen there. I'm sorry. The small cube, there's the volume. It's saying that the small cube side length, so because it's a cube, length, width, and height are all the same. It's 1.5 inches less than this one. So this side length is going to be x minus 1.5. So that's where I got that. Cubed equals 85. Now I will take the cubed root of both sides, or you could raise both sides to the 1/3, same thing. The cubed root of 85, I have no clue. The cubed root. I'm going to keep 3 decimal places, so I'm going to call that 4. I'm just going to call it 4.4. Now I will go ahead and solve. So I'll add 1.5 to both sides and I'll get 5.9. So x is 5.9. I don't know if that's what we're looking for. Let's go back over and check it out. Larger cube, what is the volume of the larger cube? So if that means that the larger cube is basically, if I have a cube, right? That's just kind of the corner of it. I can't draw cubes, but you get the point, right? That means that the height is 5.9, the width is 5.9, the length is 5.9, all the dimensions are 5.9. So what I would do is I would take 5.9 and cube it, and that would give me unless I screwed it up, 205.379. 205.379. So this is telling me that the volume of the larger cube is 205.379 inches cubed. As you're looking at this stuff, if you have any questions about it, if you want me to go through another problem, I can pick out, or we can look at any of these other problems on any of these pages. Just shoot me an email, stay after class, and we can look at anything you'd want to.